Now we have seen sufficient functions of Python, and we have also seen input statement, we have also seen print statement. Now let us try to write some of the engineering applications specifically related to civil engineering. Now the very first example which we are going to take is the conversion of the distance. So let us say the distance is given in centimeters now, and our objective is to convert that distance into inches. So the conversion factor is 2.54. So we know that 1 inch is equivalent to 2.5 centimeters. So if the distance is given in centimeters, all we have to do is divide that particular number by 2.54 constant. So let us try to write a program. So let us take input from the user, say distance in centimeters. So I am going to use a variable called as CMS, and if I want to take input from the user, so I just need to write input, and here I am going to give message enter distance in centimeters. Okay, but if you write only input, it will be treated as a string. So better you convert this into a float or maybe an integer. So I am using float over here, so that whatever value is given by the user, it will be converted into float. Now the distance in inches will be simply CMS divided by 2.54, and all I have to do is just print the value of INCH inches. Let us try this. So if I execute this, see what is happening. It is asking me what is the distance in centimeters. So let us say 10 centimeters is there. So my output will be 3.937 inches. But here it is not displaying any unit. So if you want to have a proper output, you can always say that distance is and then inches, and I am going to give unit by simple print function. So inches. So now if I execute this code, so 10 centimeter is the distance. So I can get distance is 3.937 inches. Again, you can see here the number is printed with so many decimal numbers. So we can restrict this using a format specifier. So for format specifier, I can use this, that is percent %.2f this and percent, right? So if I execute this one more time, if I go for 10 centimeters, so output will be 3.94 inches. Now let us see one more example. This is the example where I need to calculate the area of a simple triangle. So usually triangle is defined by base and its height, and the area of the triangle is half of base into height. So we can take b and h as a variable respective to base and height of the triangle, and then we can get the area. So let us write a Python program using Jupyter Notebook. So I am using b as a base, so I am saying float, say input, and message I am going to give to the user that enter base of the triangle. Okay, I can copy this and I can use the same thing for height of the triangle. All I have to do is just change the message and the variable, right? Now if you want to calculate area, so area is half of base into height, so I am saying b into h divided by 2, and let us print the area. So again, if you directly print it, it is going to give you a value with lot many decimal places. So here I am writing area equal to, and here I can simply say area, and we can add units as well over here. So enter the base of the triangle, say in CMS, that is in centimeters. So this is also in CMS. So the area of the triangle will be square centimeters. Okay, now if I execute this, see what is going to happen. So here let us say base is 2 and height is 3. So the area is 3 centimeter square. Okay, now here since the numbers are 2 and 3, those are the whole numbers, so I am going to get output as 3.0. What if I give some different values? So let us execute this. So I am saying 3.648 and the triangle height is 8.95. So in this case you will find the number is getting printed with 4 digits after the decimal. So if you want to restrict this, so you can use a format specifier over here. Using format specifier, I can say %.2f and this one. Okay. So now if I execute this, I should be able to get output in a proper format. So this is 3.5486 and the height of the triangle may be these many digits. So now you can see the area of the triangle is 15.92 square centimeters. Now this is the example of a township. So on your screen you can see there are plots in a township, and the one plot which is highlighted on the screen is of size say 30 feet by 30 feet. It's a square plot. Now I want to calculate the area of the plot. So here both the dimensions, that is height and the width of the square shape, they are same. So I just need to add a square operator over here and I can get the area of the plot. Let us see a Python program. Okay, so I am using the side of the plot as b. So this is in feet, so I'll say float and input, and here I'll say enter side of the square plot in feet. Okay, and the area can be simply b double star 2, that is the square of this. Okay, now I can use the same print statement over here because the area variable is same over here, and I can get the appropriate output. So let us execute this. So if the area of the plot is say 30 feet, the side of the plot is say 30 feet, I am going to get area of the plot as 900 square centimeters. So I need to change this to feet. Okay, let us execute this once again. So if the one side of the square plot is 30, I should be able to get 900 square feet is the area of the plot. Let us see one more example. Now in this example, let us see a plot which is just next to the earlier plot. This is a trapezoidal shape plot. So we have one side which is smaller, one side which is larger, and the height or the distance between these two sides is, let us say, 32 or 30 feet. So I am taking the smaller side as 32, the larger side as 35.5, and the vertical side is 30. So this is a simple trapezoidal shape plot. So all I have to do is use an appropriate equation to get the area of this plot. So for this, I just going to take the average of this side and multiply it with the vertical line. So let us try this in a Jupyter notebook. So here I'll say I'm going to use one variable L1. So here I'll say float input, and here I can say enter larger side or smaller side, I can say side of the plot. Okay, I can use the same line, and then I can use this as L2 where I can say larger. Okay, and I need to have the perpendicular distance, let us say h. Okay, so I can write over here float input and enter vertical distance. Okay, now you can have units also in feet. Okay, every distance should be given in feet. Okay, so I'm using this in feet. So if I want to calculate area, now the equation will be the average of L1 and L2. So I'm going to say L1 plus L2 bracket complete multiplied by, now you have height. Then again I can use the same area statement so that the output will be in a proper formatted way. So let us execute this. If you take a average, you have to divide it by 2 also. Let us execute this now. So the smaller side is coming out to be 32, the larger side is 35.5, and the vertical distance is 30 feet. Now it is going to give us the area as 1012.5 square feet. Let us try one more example. Now again we are looking at the same layout, but the plot is now changed. So this plot is a corner plot, and as you know that corner plot has got one corner having a round shape. So we need to calculate the area of this particular plot. Now we are assuming that it is a rectangular kind of a shape with one corner as rounded. So I am assuming that the larger distance is 34, the smaller distance is 32.15, and the radius of curvature at the corner is say 2.5 feet. So the easiest way to calculate the area of this corner plot is, first you calculate the area of the complete plot, then you can deduct a square shape of having side 2.5 and 2.5, and then you can add this curved shape so that you can get this particular shape which is highlighted in blue color. So the equation which can be developed over here is this side into this side, so that is 34 into 32.15 minus we have square of 2.5 plus the area of the circle divided by 4. So area of the circle is pi r square divided by 4. So this is going to give me this area. So let us try this on Jupyter Notebook. So we have now L1 and L2, that is one side larger side and one side smaller side. Now in place of this height, now I can have radius. So I am using r variable. So enter radius in feet. Okay. Now area. So area can be calculated as L1 into L2. So this is going to give me a area of complete rectangle. Now from this I need to deduct the 2.5 into 2.5, which is r square. So I'll simply say in bracket r to the power 2, and then I have to add pi r square divided by 4. Now since I have to use pi, I can use import math first. Okay. So here I'll say import math, and if I want to use the value of pi, I should say math dot pi multiplied by r square, that is r to the power 2 divided by 4. So this is going to give me a area. Now if you want to print the area in appropriate format, I just need to copy and paste this particular line. Let us execute this. So the L1 value, it is coming out to be 32.15, and the other value is 34, and the radius is now 2.5. So the area of the plot is now coming out to be 1091.76 square feet. Let us see one more example. Now this is the example of engineering mechanics, and we all know that there is a force, and the force has got two components, that is Fx and Fy. Now in this program, the Fx value and Fy value, that is the x component and y component of the force, is given. You need to calculate the resultant, and you also need to calculate the angle which is made by the resultant with the x-axis. So to calculate the resultant, the equation is very simple, that is square root of Fx square plus Fy square, and the angle can be calculated as tan inverse of Fy by Fx, that is the opposite side divided by the adjacent side. So let us try to execute this code in Python notebook. So let us take the value of Fx from the user. So I'll say Fx, so this can be float, input, here enter x component of a force in, let us say, newtons. So I can copy this same thing for the y. Now I am using Fy as a variable, and this will be y component. Okay. Now if you want to calculate the resultant, so resultant value is r, that is square root. So square root is available in math library. So I'll say math dot sqrt. Now here I am using math. I am not importing it once again, because in the earlier program import math has already been done. So I don't have to rewrite this over here, that is at the beginning of this code. So r is square root of, in bracket we have Fx square to it plus Fy and square to it. So here if you want to have print, so I'll say print, I'll say resultant equal to, and I'll say simply R. Okay, let us try this. So I have x component as 10 newtons, y component as say 10 newtons. So my resultant is 14.1421, and there is a large number of digits which are printed over here. So if you want to restrict this, so you can always use a format specifier as %.2, and we can have a percent symbol over here. Okay, a 0.2f. So let us execute this once again. So I'll say 10, 10, and I'm going to get resultant as 14.14. But here I missed the unit of the resultant. So I can always write unit of the resultant over here as newtons. Okay. So let us execute this once again. So 10 and 10. So I'm going to get resultant as 14.14 Newton. Now let us try to write the value of angle which is made by the resultant with respect to the x-axis. So angle will be tan inverse. So that is math dot a tan. If you use simple tan, it will be a simple tan value, and if you use tan inverse, so you have to write a tan. So this is opposite side, that is Fy, and divided by Fx, right? So here I want to print the angle value. So print angle say equal to, and here I'll say angle. Now if I execute this at this moment, what will happen? Fy by Fx and whatever value is there, the inverse of tan will be calculated and it will be stored into the angle and it will be printed over here. But in the previous video, we have seen that a tan, whenever it is going to be executed, it is going to give you the value in radians, not in the degrees. So usually we are interested in degrees, so we have to convert this into degrees first. Before that, let us execute this. So if I give 10 value and 10 value, so Fx is 10, Fy is 10, so angle should be 45 degree. So what I am going to get is 0.7853 and 9. So this is 45 degrees, but it is getting printed over here in radians. So we need to convert this in radians. So to convert this into radians, all I have to do is convert this into radians. So I am going to use math dot degrees. Okay. So now if you see over here, I am going to get 10 and 10. I should get 45.0 as angle. Okay. Here if you want, you can use a format specifier over here, %.2f, and you can say angle over here, and if you want to have output in degrees, so here you can say degrees. Okay. So now this is complete. Let us execute this. So I have 10 x component 10 newtons, and this time I am using 20 kilonewtons as y component. So we can see the resultant is now 22.36 newtons and the angle is now 63.43 degrees. Let us see one more example. So this is once again a conversion example. Usually the temperature is having two units, one is in Fahrenheit and one is in Celsius. So the conversion of Fahrenheit into Celsius, the formula is there on your screen, that is F minus 32 into 5 by 9. So this is going to give the value of temperature in Celsius. So let us try to write the Python code for this. So I want to take temperature as input in Fahrenheit. So I'll say F equals to say float, and here input, say enter temperature in Fahrenheit. So I'll say this is going to give me the temperature in Fahrenheit. So if you want to convert this into Celsius, the equation is very simple, that is F minus 32. Okay, this is 32, and then we have multiplied by 5 divided by 9. So this is going to convert the temperature from Fahrenheit to Celsius. So if you want to print the output, all I need to do is say temperature say equals to, I'll say C, that is temperature in Celsius. So if you execute this, so let us say this is 100 degrees Fahrenheit. So 100 degrees Fahrenheit is equivalent to 37.777 degrees Celsius. So here two things are missing. First one is the unit of output temperature, and secondly the digits which are getting printed after the decimal part. So here first of all I'll use a unit over here. This is Celsius, and if you want to use only two digits, so I should write %.2 F and then percent. So this is going to print only two decimals, two digits after the decimal. So let us execute this. So 100 degrees Fahrenheit is now equivalent to 37.78 degrees Celsius. Let us see one more example. So on your screen you can see there is a stack of bricks, and one of the most common question which is asked to the students, that how many bricks are there in that particular stack of brick. So as per Wikipedia, the standard dimensions of the brick are given as 215 mm by 102.5 mm and 65 millimeters. So approximate, if you multiply all three dimensions, you are going to get the volume of one brick, and the volume of one brick is coming out to be 1.432 10⁻³ meter cube. So if you have the volume of the complete stack of the brick, you should be able to divide it with the volume of one brick, so that you can approximately get how many number of bricks are there in that stack. So let us try to write a program for this, where I can take input as the dimensions of the stack and output will be number of bricks which are available in the stack. Right. So I'm using L as one variable. So float input, say enter length of brick stack in meters. Okay, I can use the same statement and I can say B as width. Okay, and I can use the same statement with H as height. All right. So the volume of one brick is already known to us. So number of bricks can be calculated as, so volume of that stack is L into B into H. So this is the volume of stack of brick, and the volume of one brick is 1.432 into 10⁻³ So the number of bricks can be, so print say number of bricks are, okay, all I have to do is just say n. Now if you execute this, so what is going to happen? So I am using 1 meter cube of brick, so this will be 1 length, 1 meter width, 1 meter height. So tentatively you can see the number of bricks are 698.32, but usually the bricks are not in decimal, they are having only the whole part. So all I have to do is I can round off this particular number using a simple round function. So I'll simply say in bracket round. Okay, we have already seen the round function in the previous videos. So let us execute this one more time. So 1 meter length, 1 meter width and 1 meter height. So the number of bricks which are there in that stack, approximately they are 698 numbers. So on similar lines, you can develop a few more codes related to civil engineering. Thank you very much.